1-1, we left off with what? Function. There we go. We had taken care of 4A, 4B, 4C. We seem to do okay with it. Show me. Can you do it? So not really a daily check, but a more of a let's get back in math mode. Down at the bottom of that page, there was a couple of extra practice problems. Give it a whirl. And we'll see who remembers what about radicals and how to simplify them. At everyone who just came out of Algebra 2. Yeah, it's example 4, bottom of the page. Give it a whirl. No buzz. I suppose I should not be a hypocrite. I'm pretty sure mine's still on too. Yeah, it is. Oops. It's 1, 7, 5. 4, 1, 3. 2, 1, 1. Cool. And Sam, how did he go to this?
No, Cody, I need to hear my first time. You said practice.
It was Eli. Oh. See, if you want to get good with that, you got to make sure that your hands are up to snuff by practicing. Feel how squishy that thing is after squishing on it all the time. I had to do lots of rehab on this hand after surgery, so you just sit there with a tennis ball all day. Do we got him? Let's work. Yes, you do. Plug the thing in. Anywhere there's an A, put this.
I probably should already know this, but.
Uh-huh. Also, YouTube. Wake up, Frank. Yep. Okay. The idea behind these functions was f is the name of the function. F of thing is telling you your input for the function. The name of the function, we'll call him Fred, has this programming, this code, this machinery inside the function. Its purpose is to take -3 times the square root of a thing squared plus 9. That is its purpose. So that's what it does every time. It's -3 times square root of thing squared plus 9. That is its purpose. -3 square root of thing squared plus 9. That is its purpose. That is its thing. That's what it does every time. F is the name of the function. F of x, f of a, f of 4, whatever it is. It's telling you the input. This is the button I will press. This is the code or machinery attached to that input. So if my input is, here, we'll do purple and yellow for all of our perennial choke artist fans. Vikings suck. I'm going to put 4 in there. I'm going to put 3a in there. I'm going to put a plus 1 in there. Right? That's it. You plug those in, and then you simplify them as best you can. Contestant 1. 4 squared is 16. 16 plus 9 is 25. That's -3 square root of 25. So that's -3 by 5 is -15. Done. Contestant 2. Let's see who goofed it. 3a, we said yesterday, make sure you put them in parentheses. Don't square like a freshman. That is not 3a squared. What is it? 9a squared, right? So -3 by square root of 9a squared plus 9. Now, I will get kids who try to do this. I'm about to do some not safe for school math here. Close your eyes, children. That is freshman math right there. Don't you dare. What's allowed to come out of radicals? Okay, I'm hearing kids say something multiples, multiply, because it is about factors. What times itself makes this thing. Those aren't factors because there's a plus sign in there. You can't take a 9 out. You can't take an a out right now because they're not factors. That's a sum and those are addends. Could I change that expression so it's thing times thing? How? I can factor inside of it, calling that -3 root of. If I take that out, now we have an a squared plus 1. Now it's 9 times a thing. Now I can take that out of radical town. I couldn't before, but now square root of 9 is 3. What's outside of radical land gets to party, and now we have a -9 root of a squared plus 1. Again, don't you dare try to take an a out of there, because that a squared is not being multiplied by a thing, it's a squared plus 1. Think of those like in parentheses, attached, permanently hitched together. I can't take anything out of radical town if they're addends. If I'm ever adding or subtracting, those won't come out. That's the final answer. Contestant 3. Square, but not like a freshman. Yesterday we said either you need to write out a plus 1 times a plus 1 and go spaghetti monster foil on it, box method, whatever your jam is. Or if you remember the trick, square the first term, square the second term, multiply them and double it, because you're going to have two of those terms in the middle. And then, because I'm adding 9 on there, I'll say it's plus 10, combined like terms. Now, again, I'm not taking an a out of here. Those are addends. I am adding together things. They're not factors. I can't take it out of radical town. What? All right. If I was able to write something like a plus 3 the quantity squared, see how that's it doesn't equal that. It doesn't equal that. If I was able to write it like that, isn't that this binomial times this binomial? Something squared. Now I'd be able to take the entire a plus 3 out of radical town, but it ain't. So since I can't rewrite this expression as two factors being multiplied, is done. That's it. That's the answer. Sometimes it just stays ugly. Y'all are teenagers. You remember that point somewhere between middle school and high school when you started realizing the simplest it gets is still pretty friggin' ugly? The easiest it gets is still pretty complicated? Okay. Well, there you go. It just stays ugly. So, we're talking about functions. We talked about domain, range, the difference between a function versus its related equation, specifically the naming conventions on these. F of x is not just a fancy y. F is the name of the function with your input, which gets you the rule, which gets you the output. Okay? They're talking about the same object in different contexts. Here's where we start to separate out I know algebra 1 versus I know algebra 2. The domains. Okay, off to the side, we've already talked about these. The commandments of domain. And Mathocles comes down from the hill with the big stone tablet and says, number 1, thou shalt not. What? Don't you dare divide by 0. Okay, thou shalt not divide by 0. I can't take something and divide it into 0 pieces. 2, thou shalt not even root of negative numbers. It's not possible, right? Nothing times itself makes a negative number. And then kids start to say, well, I. No, I is imaginary. We literally made it up so we can work with them. Okay? Sometimes you need think of it like a really, really bad coping mechanism to get through trauma. Okay? Sometimes you do something really, really bad that you shouldn't be doing, but it let you survive at the last 3 years. Okay? I can't do that. I can represent it with I, but we can't actually see that on a number line. Okay? Because it breaks second commandment of domain. Third commandment of domain that you saw in Algebra 2, those ones we already knew from Algebra 1. Then we got round 3, and it was, thou shalt not take log any base of a non-positive. I cannot take the log of a negative number. I can't take the log of 0. Doesn't matter what base I'm using. It's just not allowed. Anyone remember why? What feature exists on a logarithm graph at 0? Those of you who just took your final 2.5 weeks ago. Asymptote. There's a vertical asymptote at 0. Just like exponential graphs have a horizontal asymptote at y equals 0. Remember, it curls along, curls along, curls along, takes off. Logarithmic graph has a vertical asymptote at 0. Curls along, curls along, curls along, takes off. Nothing exists back here. From 0 back to negative town, there is nothing on that graph. So that is my third commandment of domain. My fourth, the further you go, you start getting into more specifics. We don't know yet. To be continued. We'll hit that in chapter 4. Or to be determined, how about? Okay. We're going to get those in chapter 4. Okay, that's where we start laying the foundation for trigonometry. So, if those are my commandments of domain, you have to remember that domain, x values, input. Domain is asking, what numbers am I allowed to put into this thing? But like a lot of, I don't know, a lot of Eurocentric religions, it's more about what you're not allowed to do. This is saying, what is going to break my rules? That's how I make domain. Who's not allowed to my party? Okay? If the rules of my party are very simple, don't mess around with my cat, don't eat my goldfish, take your shoes off at the door. As long as you follow those 3 rules, you're good. Look at A. Which of those 3 rules might this break? I can't divide by 0. So you find out who's going to break the rule. I find that out by taking my denominator and set it equal to 0. I'm saying who's going to break the rule. Good thing I know how to solve quadratics. Okay, how? What's the very, very first stop on any factor train? Greatest common factor. If I take out x, I got x minus 7. If I have thing times thing equals 0, then both of them might be 0. I say 0 and 7 respectively. So, those are the 2 that are going to break my rules. Okay. I have 3 simple rules. I look at the guest list and, uh-oh, Jacob is going to eat my goldfish.
No.
And Connor is going to be doing who knows what with my cat.
What is that supposed to
Okay.
Yo.
Maybe he's got a laser pen in there and it makes the cat dizzy. Teenagers, jeez. Whole bunch of dirty minds. Okay. So, how do I say these are not allowed? Everyone else is allowed, but not these guys. We did domain, right? By set builder and interval notation. Okay. Infinity stuff. Okay. 2 ways. Way number one, set builder. I say all x's such that my rule is just Connor and Jacob are not allowed to my party. Well, stop messing with my cat. But X is element to the reals because literally everyone else is allowed to my party. Okay, that's how we find domain, is you single out who's not allowed and say everyone else is cool. Now, if I was going to do that by interval notation, okay, you don't have to draw this part unless you want it as a reminder. But if I had a number line from negative infinity to infinity, at 0 and at 7, how do I show, remember good old one variable graphs, how do I show not this? Open circles. Open circle here, open circle here. So what else is shaded? Literally everything else. All of this, and all of this, and all of this. Do you remember how to say that using intervals? Negative infinity, all the way to 0. To exclude it, do I use parentheses or brackets? Parentheses. Brackets means it equals. Watch the video, dude. Parenthesis and a union means can't touch this. And then I pick right back up at 0 and I keep going. From 0 until 7, and then can't touch this. And 7 to infinity. This is why when we were talking about intervals yesterday, I had said you need to write them in numerical order, is if I do this right, shouldn't my domain written in interval notation just match the number line? And you put the parenthesis union right on top of the guy you're saying no. Okay? So if you need to come back to this number line, go for it. But either one of those is acceptable. Purple and green, both set builder and interval notation, they're both allowed. It doesn't say which one you have to do, and we're going to use a little bit of both. We tend to go more towards interval most of the time, but both are legal. B, which of my commandments might this break? Okay. Every time Holly comes over, she never takes her shoes off. She's like tromping through the house and there's like mud everywhere. Just, no. That one isn't allowed. So, if I'm not allowed to take, okay, I'm not allowed to take the square root of negatives. Can I take the square root of 0? Ooh, there. Yes, question mark? Y'all got a calculator, try it. What's the square root of 0? 0. So, I'm going to set this equal to 0 because that's going to be my dividing line between I can and I can't. And I get something nice and simple, t is 5. So when I put in 5, is it cool or not? Yeah, that works. Again, think of number line. So at 5 it works, so I'm going to have a closed circle. Am I allowed to put in numbers smaller than that or bigger than that? Because what happens when I put in 4? We have broken the second commandment of domain. So really it's t is greater than or equal to 5 are the ones that are allowed. How do I write that in set builder and interval notation? In set builder, we say all x's such that, what's my rule? Just that, right? Oh wait, these aren't x's. T's. All t's such that t is greater than or equal to 5. What number set am I a part of? Real sets, right? Real numbers, because I can pick 5.1. I can pick 3 pi. All of that stuff is greater than or equal to, so I will say t is an element of the reals. If I was going to do that in interval notation, boy, does that get easy. What's my lower boundary? 5. What's my upper boundary? Infinitum. Can I equal 5? Parenthesis or bracket. Okay, bracket means equal. Can I equal infinity? Nope. So, that's it. Like, that's the answer. Do you see why we normally gravitate towards interval instead? Okay. C got a little cut off. That's x squared minus 9. Make this a little bigger. Right. So, what commandments might I be breaking here? Can't do square root of negatives. I also can't divide by 0. So I got to watch both of them. This is that kid who just enjoys pressing buttons and wants to break the rules. Okay. Now Riley came over and he's like, kitty, goldfish. Now he's going to break both rules. So we have to watch out. X squared minus 9 equal to 0. So x squared is 9. How do I undo x squared? And if I put the square root there, plus or minus 3. This is where that number line comes in handy. At -3 and +3. What happens to this thing if I put -3 into the equation? -3 squared is 9. 9 minus 9. Can I take square root of 0? I can, but I can't divide by 0. So I'm going to put an open circle on these guys. Now, it's not the entire number line, because I can't take square root of negatives. You got to figure out where in those regions it is. So pick a number and plug it in and see if it works or not. Throw 0 in. Does 0 work? No. Pick 4. I get square root of 7, but that's okay. That's a number. I can work with that. So this works, and put in a -4, same thing. This is where that number line can help you figure out domain. You just quick sketch it and say yes or no, open or close circle, left or right, does it equal or not, guess and check in your intervals. Now that I have this, could you write this in interval and set builder notation? In set builder, all x's such that. What are my rules? Good story, bro. How do I write this one? This half. What's the rule for this? X is less than -3. What's this rule? X is greater than +3. And can't it be in this spot or that spot? I won't use or as a compound or I won't use union as a compound inequality. I literally just shoved the word or in there. If you used a union or, remember this is or of sets. This is or in just math speak. If you use that, I'd be cool with it. But Remember seeing these all the way back to algebra half? Compound inequalities? I just did it 2 days ago with my algebra class. What number set am I allowed to be in? Real numbers again, because I can pick any number, rational or irrational. Now that set builder notation looks pretty big and ugly. This is why we tend to use interval notation, negative infinity all the way until -3, 3 all the way to infinity. If I have that number line, it just tells me what to do. Negative infinity to -3, 3 to infinity, parenthesis or bracket. Can't touch infinity. Parentheses or brackets. I heard both. Which is it? Bracket equals, parenthesis doesn't equal. Open circle means parenthesis. And the or of set land is union. Either one of those is acceptable. But it all boils down to those commandments of domain. What am I allowed to do? Who's going to break those rules? And you single them out. Little bit of each type of flavor. Tell me the domain of each. You're looking for who's going to break those math laws. The loss of the couch is felt by all. Because sometimes you just need to crash. No joke, I got one kid who actually slept more in my room last semester than they did at home because they just couldn't sleep at home. So they just pass out on the couch all the time. That's cool. Hit that like, smash that bell. Join my Patreon. And y'all getting creepy quiet again. Talk to each other. What is or is not allowed?
You're the one that you're the one that said hi first. I was reciprocating.
Okay, what are you not allowed to do? Which of those 3 rules is this thing gonna break? Typically, we start by setting either a denominator or a radicand equal to 0 and use that as our starting point.
That's awesome.
Y'all are quiet, so I'm just doing stuff. Like, talk to each other. Do some Collaborative group work already. Come on. That's either the most intense concentration ever, or y'all socially awkward and just don't want to talk to each other because you're only used to communicating with a screen. Both.
No. Wait. Wood. 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 How could you even?
It's not a joke.
I actually found that dinosaur out in a snowbank walking over to McDonald's like 4 years ago.
Yeah.
As the parent of goblins, yes. Kids leave their crap everywhere. I call them my goblins. Or my spawn. I'll go through the work, but that's what I think. Check me before I wreck me.
Wait, why is it negative? There was a million things over there.
You can't divide by 0, right?
Yeah.
Set denominator equal to 0. X plus 4, x plus 3. Solve both. -3, -4, not allowed. Have to exclude both. So you get a double union.
That makes sense.
For B, set it equal to 0. Add. What? Oh no, those are brackets! No, these are supposed to be brackets. Yep. Yup. Now. Now.
Was that not just one? When Brandon went down?
Uno.
Yes, we're on the board. Are you writing? I don't trust you. I can't see.
The other brewer.
Oh. You're up there.
It took 2 weeks, but welcome to the list of shame. Here's how this works. Every now and then, we get someone who just collectively makes the room facepalm. It's okay. It's okay. Now, we don't be vicious about it. Try to remain objective. But every now and then, Jacob is going to just open his mouth and something's going to come out. And I'm going to stop and I'm going to have a big, heavy sigh and I'm going to look at the class and say, like the Emperor of Rome, okay? Either he does or he doesn't. And after Jacob gets so many of them. He gonna bring us food.
Yeah. Everybody do that now.
The worst that I've ever seen, I had a kid who had to bring in 6 times. And that does go up just like mine. You hit 5, it goes up to 10. After that, it goes to 15. After that, it goes to 20. After that, it goes to 25. Kid had to bring in 6 times. Mostly because his friend just got annoyed with him and wanted to hit him. And so he like started making punch points and said, like they worked out a conversion rate, and it was like the stock exchange and something where so many punch points was so many points up here, so he didn't get hit. I don't know what it was, but it was a whole thing. He brought us lots of food. It was funny. It's a way for us to laugh at ourselves. Yes, I have been put on the list of shame by my own classes before. 5-8. I set that equal to 0, right? I find my 2 culprits. If I have x is either -4 or -3, I'm going to end up dividing by 0. Do you see why it's a union on -4, a union on -3? Because I have to exclude just that value. As a number line, this is all the way to -4, all the way to -3, off to infinity. I'm just excluding those 2. But when you exclude multiple values like this, sometimes you're going to get a whole bunch of unions. It's one of the few cases where set builder notation might have actually been faster. Okay, contestant 2, y'all caught it, yes. If a squared minus 4 equals 0, a squared is 4, square root, a is plus or minus 2. And if I'm looking at that number line at -2 and 2, if I plug a 0 in here, I break math law. So everything in the middle is not allowed. If I plug plus or minus 2 themselves in, it does work. I can take square root of 0. So those are going to be closed circles, and it's everything outside of them. That's why my union doesn't include the space from -2 to 2. Don't assume that happens. And then 5C, you got to mix and match. 2x plus 6 equal to 0. You say, if I put in -3, does it work or not? It works for the radical, but it doesn't work for the denominator. So I can't be at -3, and then you test bigger or smaller than that to decide which way you got to go. Cool with it? Maybe brushing a little rust off the gears? How about piecewise functions? When was the last time we saw this? Probably Algebra 1?
Yeah.
That's a bummer because they're actually super easy. These are super, super easy. She's usually pretty quiet about it.
Submarine.
I think you were more mad about that than anyone else.
Yeah.
So sometimes you're going to get a function that is broken into pieces called piecewise function. And it says, I'm going to follow this rule here. And then I'll follow this rule there. And I'll follow this rule over now. So you all know this already. Don't you follow different rules in different environments? When you're hanging out with your friends and there's no adults around versus you're in a classroom versus you're at grandma's house, isn't your behavior a little bit different, right? You have different rules. At your language, your vocabulary, when you are at grandma's house versus you are with your friends unsupervised. Any of the nerds who have hung out at the game store outside of school know that Sullivan's got a bit of a potty mouth. My filter don't work so well outside the building. It's like turning Wi-Fi off. This is going to look different, where it's going to be like from here to here, it'll do this. But then from here to here, it'll do this. And then from here to here, it'll do this. Okay? Piecewise functions. You graph them in their pieces, in their parts, and it only follows that rule in that environment, in that part of the domain. So, yeah, there's a bunch of words up here. Blah, 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 blah. I don't care. H of 67. Which of those three rules am I going to use for this? Second rule, right? 67 is from 66 to 68. So I'm going to put 67 in there. That's it. It tells you which of the rules to follow and when. I plugged 67 into this rule because 67 meets that criteria. It tells you when to use that rule. Okay, it's kind of like tax brackets, right? If you're a teenager and you make under a certain amount for standard deduction, you have to claim 0. Y'all should be getting your W-2s by now if you got a job. You should be preparing to do your taxes. Your taxes, for most of you, is going to be 0 exempt, handed in, because you don't make enough to meet the standard exemption. So you just get all your money back. But once you meet that standard exemption, I think it's 7,500 or 9,500. Once you make that much in a year, now you go up to the next bracket. Now you're in the next rule because your amount is in a different area. Your domain is different. Okay. 3 by 67, what's that? 180, 201. Insert sophomoric reference here. What about 72? Plug it into the last one. 72 is bigger than 68. So I'm going to plug that into 2 by 72 minus 66 is 144, 66, 44, 22, 78. Okay. That's it. That's what a piecewise function is. It just tells you which areas you're going to do that. Now, we're going to talk more about graphing them in a later section. Right now, it's just evaluating the functions. Okay? So, down here. Okay, the speed can be represented by the following piecewise function, where it is time in seconds. Find the speed of the vehicle at each indicated time. You decide which of those rules your input fits. Plug it in and evaluate at that part of the rule. I got a cheap calculator. Got them? Round one. Which rule am I using? First, second, or third? First rule, plug it in and just get 20. Second one, careful. It still goes into the first rule. Why? Or equal to, right? It's kind of like, y'all ever seen or played Plinko? Where you put the little disc up here and it pings down all the pegs, and then it lands in one of the buckets, right? Well, what happens when the disc hits there? It can't just hang out there, right? It has happened before. Okay, anyone who's watched Price is Right knows it can happen. But I can't hang out here. I have to pick one or the other, and that's when I look at or equal to versus greater than. And it says, nope, it's going to fall into this bucket. Okay, so it's just going to be 2 by 15 or sorry, 4 by 15, 60. And the last one, I put 245 in here as negative 6 by 245 plus 1500 is negative 1293, negative 1475, 25? Damn. That was close. I said 25. So, random tidbit. Anyone ever watch the old Mythbusters? Okay. They had a couple of different episodes where they were testing like road rage and what was it? Road rage, sleep deprivation, and distraction on driving habits and gas mileage. And the way that they were able to simulate the emotional state or distraction for everyone was to just make them drink like a gallon of water before they drove, because then they all had to pee and they had to drive around like that. So they couldn't think straight. Moral of the story, take 5 minutes. I got to use that. Take 5 minutes. If you got to go, take a break, stand up, hit each other. I don't know, do something.
Or something. What on earth? Yeah, we started. Oh, maybe about. Oh, well, I don't know. That's fine.
Yeah. I dropped the phone and caught it. You have more room, okay? Hey. Bounce it over.
There, now you are worried.
Do it. Bounce it over.
That's what the back says.
Bro! Monkey.
Okay. How you doing? What? Right, what are your
Spread it.
Like this one?
Don't hit the.
Hit the post. We're pawn shop. This is take it off that. But it's on tape. That's fun. I have friends. You will. If I have friends. But I would, they could take me to my house. Like, so that I could change it. But I don't want to do that. Because they'll suck. Not you. I would, but I won't be at my car. I'll just give you my keys. Drive safe. Did you not drive today? Oh, yeah. Oh my gosh, guys. You're gonna
Yeah,
be a boy.
Jacob, what the hell?
I think that deserves a point.
No, no, Levi.
Yeah, me
Is it
too.
pronounced
Put me up there.
It's monkey. Ah.
Remember when we looked it up and it literally said that you could survive in a submarine?
I
What was it talking about? The submarine. I don't remember.
What's submarine?
Oh my gosh,
Okay,
it's
it's a series. So basically, if there was a tsunami, like if you lived where there was a tsunami, my theory is they should, like the city should just spend a whole bunch of money on building submarines, and then you all get in the submarines and survive.
So like a Noah's Ark building?
Yeah!
No, the
No,
way
they're
waves are tall.
industrial ones.
The water tension would hold the submarine and push you on.
I don't think no, but how do normal submarines work?
You're in the water.
Yeah.
Under the water.
And they're strong enough to withstand the pressure. No, they're not. They are.
Submarine-
It's like you're going down into the depths of the ocean.
No,
that's
but
what
you
you
have
have
to
to
do.
do.
Yeah,
Yeah,
but
but no. I will. There's no change in my mind. I'm serious. Plus Google said.
Okay, but
Google
how
is
long
not
would you have it in
That's
advance?
Google.
That's
Google
Google
said
said
Google
so.
said they told me
What's
that.
the tsunami?
Google
Actually,
said
that's
that.
Look at the sign.
What would the sign
I put it.
I'll find
Oh,
it.
it's like
It's
started the submarine argument again.
The submarine argument? Okay.
No. Hit it. The sign. The noises.
Comedy.
Levi, somebody's made that. Put him on the wall. Levi. Everybody put a thumbs down for Levi.
It would not be the first time that I've just put a group of students up there as just like the Three Stooges, and that's it.
Is that them or? More of that. Knocked out cold.
Okay. Pause. Juniors in room?
Oh, is it just me?
Are you, okay.
Oh,
Are which juniors? Which ones are okay? Are any of you taking the ACT next weekend? Yes? Okay. Are any of the seniors planning on? Most seniors don't take it by second semester because you've already probably applied and been accepted places. Okay. So we started this a couple years back. I used to just do ACT review with kids on my own. Like it would be a whole night of math. It'd be after school. We'd order pizza, the whole works. And in the last couple of years, we started just kind of spreading it out over the entire week before a big ACT. The February one is a big one. Basically, every kid who was in pre-calc last semester is probably taking the ACT this next weekend. So just to let you know, if you are planning on taking it, we are going to have ACT review the math teachers. It's going to be in the announcements all week long. Some of them will be in Spartan time. Some of them will be after school. It's going to be in different rooms with different teachers. It's just we kind of draw straws and say who's available. But there will be ACT prep review for math. And I hate to break it to you, ACT, it's horribly normed on. Don't go off on rant about standardized testing. No rant. Shut it. It's about time. The ACT is about time management. Okay. Most of what we go through is a little bit of math review and we tell you how to game the test. Like if you're staring at a problem for 15 seconds and you don't have a plan yet, then you just need to move on. It is that critical. Okay. I'm bringing this out because I remember I forgot to actually put the function for this up here. 1, 2, there we go. All right, graph analysis. Old notes, forgot to do thing. We're going to have R of t is 17.7 t cubed minus 269 t squared plus 1458 t minus 910. Okay. Okay, so write that down. It's not on the page. I forgot to put it on there years ago. Oops. Okay, so that's the actual function itself. And then we're given the graph for it. This is about, can you read a graph, as we're talking about ACT review. Boy, I tell you, the science section is, do you know basic, like, freshman level science facts, and can you read a graph? That's what the science section is. It is mostly about reading graphs. Okay, seniors who have taken it before, you probably back me up on that, where science section was just a bunch of graphs. And read the problem. Okay? We have to be able to read and interpret the different aspects of a graph because chapters 1 and 2 in PreCalc are heavy on graph analysis. You're going to be good with functions. So the function is given. It is talking about the revenue in terms of time. What else could I know about this from the graph? Like, what are important aspects of a graph? The points themselves on the graph. Those points are all coordinates. Coordinates are x's and y's. Do I know what the x's and y's stand for? What do x and y axes stand for in this problem? You have to be able to read the axes, okay? Not just time, but years since 1998. Okay? That's another big one. Look at the y-axis. It's not just revenue, it's revenue in millions. So when you plug in a 6, you're going to get out a 2,000 or ballpark. You have to understand that that's not really they made $2,000. That's they made $2,000 million, which is how much? 2,000 million. Throw 6 more zeros after that. 2 trillion. Yeah. Yeah. Okay. So, you got to be able to read the axes. You have to know that the labels matter. Because how many times have you seen a graph? I think we were just talking about this the other day. I heard it again on, was it NPR? It was, they're talking about this. There's a graph that's like, this is how much, Taiwan spends on their military. This is how much the British spend on their military. This is how much the Chinese are spending on their military. And they're like, oh no, be afraid of the Chinese. And then next to it, it was like US. They used this scale for everyone else, and they put a whole different axis over here for us. Because this started up here. You have to be able to read a graph to be an informed person. Okay? Yeah. Never mind healthcare and the well-being of your citizenry. Let's just buy another fighter jet. Because dude, jets. Okay. All right. The question asks, use the graph to estimate the total internet advertising revenue in What? 2007? I got part of it's missing here. If it says to estimate in 2007, how do I do that? Because I don't see 2007 on here.
You find 2007.
Years, you have to be able to read, right? Years since to 1998. So it's 9 years after. So we'll go to the 9, and that's, they show me the dotted lines, tick, 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 and then I come over to the y-axis. Now the y-axis says, uh-oh, that's not a specific number. Can you estimate? Can you ballpark?
35. Nope.
It's 34. It would be 34.
Okay, what are the boxes each worth?
5.
Okay, each one is worth 500 of the millions, right? So if this is going by 500, 500, 500, 500, 500, this is going to be about what? Looks like it's kind of between maybe 3 and 4, 4-ish. Okay. Welcome back, sunshine. Okay. I would say about 3, I don't know. I'd do something like that. I'd kind of ballpark, right? But you have to be careful. It's that many millions of dollars. So that's how much it really is. 3.35 billion. Okay. Now that's my estimate. It says confirm it algebraically. This is why we needed the function itself. How do I confirm this algebraically? Plug it in for t. Y'all got a calculator, start pressing buttons. This is in millions, but if it's this much million, this is the million part, but it goes to the billions place value. Advertising's a lot of money. Google specifically is potentially looking at another antitrust lawsuit and a breakup from the FCC right now. When they bought Click Here about, I don't know, 10, 15 years ago, when they bought that, it was no big deal. It was just one big company bought another one. It was approved by regulators, all that kind of stuff. But now, since everyone advertises with Google platforms, they basically get to control everything. And it can restrict the flow of information and competition. And it's this kind of money. So when you start involving big money like that, people get mad. All right, I'm going to go to y equals. I'm going to type in 17.7. I have to use x. I can't use the actual t in here. To the third minus 269 x squared plus 1458 x minus 910. Okay, now we're going to see who remembers what from their Algebra 2 experience. If I don't want to just plug this in for x, which you can just parentheses plug in 9 everywhere you see an x. Perfectly fine. But I have a 2007 is 9 years after 1998. The whole point of the graph, the thing we just did. Okay. Do you remember, instead of going to a table and scrolling down until I feel 9, feel 9? I feel 9 for the rest of my life. As long I find 9, there you go. Do you remember how to change your table settings so you can just ask it these numbers? Right above Windows table settings. I'm going to switch my independent variable, my x's, over to ask. And now when I go to my table, I can just ask it a question. It's going to tell me the answer. I'm going to say, after 9 years, how much? If yours is negative, you typed in the function incorrectly. Be careful, did you use like the negative button instead of minus button? Did you miss an exponent somewhere? I don't need to calculate anything. Well, yeah, second, calculate, go find the value of. The reason I like that table is because now, y'all, the reason I like this is because it allows you to rapid fire answer multiple questions. If I asked after 9 years, plug in 9. If I said in the year 2005, how many years after 1998 is that? Okay, bam, answer. What if I said in the year 2023? How many years after 1998 is that? Womp. Okay. Now, these columns are only so big. This 9, I hope you didn't just write down 33 or 3326.3. If you arrow over, if there's any more after it, it will display it. Oh, these are all cut off. Okay, there you go. So like this one, it's got more to it. So just be aware, if you highlight the cell, it'll tell you the full value at the bottom. It's only going to give you so much space. Like, have you ever seen when you get scientific notation in there instead? Like, say I put in something ridiculous, 300 years out. Uh-oh, it does this. Well, I know that that's 4.54 times 10 to the 8th. So 1, 2, 3, 4, 5, 6, 7, 8. But if I just went up and highlighted the cell, it would tell me that. Okay? So just be aware, there's tools where you don't have to plug in the number. You can use the tools to do that for you. All right. What else we got? Down here, use graph to estimate the year in which the advertising reached $2 billion. This is why we have to be able to read the graph scale. Because if you look at the side of that and it says $2 billion, I don't see 2 billion anywhere on there. These are all like thousands. Where do I go on the graph? So if it's in millions, which of those is 2 billion? Y'all write 2 billion, right? To the thousands, to the millions, to the billions. And then my scale is in millions. Go look at 2000. Okay? So we'll go to 2000, brrr, come on down, and I'm definitely not just going to write 6. Why not? Years since 1998. When does this happen? Think before opening your mouth hole. Okay?
It's 9:30.
So, it says to confirm this algebraically, what am I plugging in? X or Y, or in this case, T or R of T. Okay, can you plug in 2 billion into T? R of T is the revenue, isn't it? Now, in the function, it is going to show up as 2000. We just know that it's more than that. Do you remember how to plug in a y value when you're on a graph instead? Okay. That's how it should work. That's not how it actually works. You would think I should be able to switch my dependent variable over to ask instead, and it should give me the x that goes with it. It doesn't. I don't know why, and I have never met a teacher who understands why that doesn't work the way it looks like it works. It just doesn't. You know, write angry letters to Texas Instruments. Instead, how about I get the graph for this? Just go and hit graph. I'm going to turn my stat plots on. I still got stuff from yesterday in here. Okay. So if I go to a typical graph, it's thinking, it's thinking, it's thinking, and I get what looks like just a vertical line. Because look at the window that we have displayed. Literally, it's giving you the dimensions of your window. Go to your window and make it match. Say, I'm going to go from 0 to 10, going by ones. My y's are going to go from 0 to 5,000. And I'm going to go by 500s per box. Okay, because that's exactly what the graph was that I was shown. Now when I graph, I should see the exact same thing. Literally the window on the graph in front of you. 0 to 10, 0 to 5,000. Okay? Does anyone remember how you actually get the grid line on here so you can see stuff better? I do not recommend it on older calculators because of how pixelated they are. I only recommend it on something that's got a color screen. But you can, second format, I can turn my grid lines on. Since I made my intervals go by 1s and 500s respectively, I should now get the exact same graph that's on my paper. Okay? Now we said we want to know when this hits $2 billion, which is 2,000 in the function. And it was a y value. How do I find that if I can't use that cheater feature with the table? I could trace and ballpark it. I could trace and say, not quite, not quite. Come on, Frank, let's go. Getting warmer. Oh, how do I know which one to choose? $1997 versus 2009. How do I know what to choose? Uh-huh. Go to bed earlier. I would choose this one because it's closer. Okay, now this is how you ballpark. How do I get the exact value? Don't I want to know when the y is 2,000? Y'all remember this from Algebra 2? We did it a few times. I plug in 2,000 into y2, and now my graph is going to say 2,000 hits my graph, and I can go calculate my intersection. As long as it's on the two different graphs, it doesn't actually matter where Blinky is. Here, and guess, I don't care, tell me the answer. Okay. Do you remember how to get that even more explicit? So this is 6 years after 2000 or after 1998. So it's in 2004, we know that. A little bit of unit analysis as we talk about review for different tests. How could I make this more specific than just in 2004? .1524349. I've got that much of a year into 2004. So, is 2004 a leap year or not? Divisible by 4, so yes. So I'm going to take .1524349 times 366 days. It's that many days into 2004. Well, let's get January out of there. That's 31 days. February 24th, 2004. Could I get more specific? Take that 24 out of there, and I've got this much of a day. Take that times 24 hours. Six something. 24 hours. Okay. Get that 18 out of there. Take that times 60 minutes. This is unit analysis, and it is going to come back to us later in this class. At 6:59 on February 24th, 2004, it hit exactly 2 billion in revenue.
Wow.
Have you ever done that in any of your classes? Could you?
Probably could.
Okay. Because maybe someone includes that on an assignment or a quiz, because we should be able to do basic unit analysis.
Oh, the perfect. See, these are the same.
I think we've got enough time to do it, but I'm going to cut it off because my third block pre-calc is, they are consistently about 10 minutes slower than you. So there you go. Maybe it's just my caffeine is more in effect in the morning. I don't know. Okay, so we're going to do more of this tomorrow, graph analysis. Y'all, remember, tomorrow is early release schedule. We are only in here for 60 minutes. That'll be enough for us to finish 1-2, and that's it. And then Thursday is our next quiz. On Thursday, you should turn in your Chapter 0 packet. Okay? Who do what?
Spartan time.
Spartan time today test? Yes. That's my inclusion algebra class.